Hello guys, how are you? I'm thinking that you are enjoying a lot in the signal system, in which we have already discussed about the signal, various types of signal, along with some example to understand the property of the impulse as well as the step signal and the ramp signal. Now we will get good for the discrete type of signal. Basically, we have discussed the time that is continuous. Now we will discuss about the in discrete time. Okay, that is the first one is the unit sequence signal, unit step sequence. What is it? We will discuss. Okay, now see. Unit steps is basically clear from its name itself, unit. And the steps, that means the step should be the one. That means it is defined for at an equal interval of time, that is at 1 unit. That's 0, 1, 2, 3. That means its amplitude is 1. Okay. That means u of n equals to what? U of n equals to 1 for n is greater than or equals to 0. Because for equals to 0, for it's 0. Otherwise it's 0 for less than 0. Okay. Only for this one. Here it is not. Okay. It is okay. It is predefined discrete signals, not quantized of continuous. Okay. Why it is equals to at 0 also equals, means at u of 0 is equals to 1 because it is predefined discrete signal. It's not quantized of continuous. Okay. It's not of continuous amplitude to discrete amplitude. Okay. Now see the discrete impulse, or we can say it is Kronecker delta. It's also called Kronecker delta or discrete impulse, that is represented by delta of n equals to 1. Okay, for n equals to 0 and 0 for is not equals to 0. That means this at 0 its value is 1. Okay, at n equals to 0 its value is 1, but we know that del of t at 0 is infinity at n equals to that at t equals to 0. We have already seen. So this is nothing but this one. Now property, we know that the integration or differentiation of the unit steps signals is what? Is nothing but impulse. So we have already seen before that integration as well as differentiation of the unit step signal is nothing but this impulse signal. So it is what called? It is called differentiation, or in a discrete it is called differentiation, and in discrete it's called difference. Okay, got it? Like you can write here this is differentiation, and we can write here in discrete form like x equals to xn minus 1. That is this form, delta of n. That means impulse function of n discrete equals to u of n minus 1. Okay. Now see how this is derived. It's very logical. You know that this is of u of n. If we subtract 0, 1, 2, 3, if we subtract 1, 2, 3, this one, then it is what? And of course at 0 only we are getting 1. Okay. So basically, similarly, this is for differentiation. And if we talk about the integration means summation. Now, integration, you already know that root equals to minus infinity to t del of t d tau. Okay, and that is nothing but the integration. And in discrete, it is for continuous. But when we talk about discrete, it is called summation. It is what called? It is called summation. Okay, where integration is represented by delta summations. Okay, and t is represented by the continuous interval of time. Continuous time is represented by discrete, okay, at a certain interval of time from every instant t to converted to n certain interval of time where tau is represented by k. Okay, now we can represent here u of n equals to summation from k equals to minus infinity to n into del of k. Okay, del of k is called del of k, no problem. Now we can write here, we can substitute the value of n. Let's suppose that let n minus k equals to n. Let's assume, okay. Now let take k equals to infinity. K equals to infinity. And n equals to what? N equals to minus infinity. When k equals to n, that means n equals to 0 here, n equals to plus infinity. So we can write this as u of n equals to summation from m equals to minus infinity, na? Minus infinity to n into summation of k equals to n minus. This is discrete formula, or we can simply write here u of n equals to same thing, n equals to 0. Okay. See man, it is 0 now, so it is what? At n it is 0, and so minus infinity to 0 delta of n minus n, because it's even signal, so reversing of this is not a problem. Now see one, that always remember that scaling is the value is always remain same. So that means del of that means scaling del of n is equals to 1 for value n equals to 0 and 0 for n not equals to 0. Similarly, delta of 4n will be also 1 for n equals to 0. Delta of 4n equals to 0 for n equals to not 0. So continuous signal only represent for an area or all other point. Continuous signal only represent for an area. Okay. So while all of them 4 amplitude. Okay. Now clear. Now see the different type of transformation we will discuss. Transformation of signal. You know what are the operation which are performing on signal? That is nothing but transformation. For operation to perform, we can convert into one formula. One is the time scaling. Time scaling like x of et, okay, from x of t. Okay, so how from x of t to x of at, or we can write it as x of m, okay, for discrete x of n, okay. Second, time shifting, time shift, that means x of t to x of t minus t naught shifted by t naught, or x of n equals to x of n minus n, okay. Okay. Now it is time shifting. We have shifted the time. It is what equals to t naught. Means it is advance. Okay. Similarly, time reversal means x of t2, x of minus t, where x of n2, x of minus n. Okay, clear now? Okay, and finally the time reversal, and again the final one is nothing but amplitude shifting, amplitude scaling, like k of x of t equals to, or like x of t scaled by amplitude scaled by k, or k into x of n. Okay, so this is called amplitude scaling. So in time scaling, basically we have just multiplied by any constant. We have just scaling. That means we are either compression or other expanding, or other decimations or interpolations. So decimation means compression. This is the decimations. So compression. That means other expansion, other compression. Expansion means jayega. Okay, decompression is decompressed hoga. So in discrete, so this is for continuous. In time scaling, we can see that expanding as well as compression is in discrete called decimations, and expanding is called interpolations. Now time shifting, here it is time advance if it is t minus t naught. That means in the real time it is not possible. Okay, in advance. It's time reversals like this, reversal of time axis. Okay, amplitude scaling, we are just multiply the by constant with the amplitude. Okay, you know, CD burning, one very interesting is there. Okay, we'll see in the next. Okay, one by one from the time scaling we will discuss. Now let's see. Now one interesting thing I would just like to share with you, that in signal processing, okay, okay, so real time is online. रियल टाइम क्या होता है? ऑनलाइन. जो देखते हैं हम इसमें हम रिवर्सल नॉट पॉसिबल. लेकिन जो नॉन रियल टाइम है, जो ऑफलाइन वीडियो है, उसमें हम बैक कर सकते हैं वीडियो को. दैट मीन्स रिवर्सल पॉसिबल. दैट इज पॉसिबल. दैट मीन्स नेगेटिव ऑफ टाइम इसमें non-reversal, that is offline video. Whatever we have seen video. There is one question from the reported examination, that CD burning, regarding CD burning, that if xt is a signal and that is burning at y rpm, okay, that is 60 minutes. Then if it is time is what? Scaled by 2t, then gain is by 2y rpm. If it is by 2, that means scaled by 1 by 2, then again the rpm would be 1 by 2 rpm. So rpm does not have any effect, okay, in this product. Okay. Now we will see the time scale. Okay. Now we will see the time scaling property. That let us suppose that I think we are having problem on that. Let us suppose that this what time scaling. Okay, now we are talking about time scaling. See, time scaling, what we have done, I just multiply by any constant with the time. Okay, like suppose this is a signal that is from -1 to 1, okay, and this is the xt, and time is t, so that is xt. Okay, that means xt value is 1 for the t should be greater between -1 to +1. Similarly, if we scale the time by x of t, then what? There is nothing but -1/2 okay. Nothing but 1 between -1/2 1/2. Okay, if we time scale this thing, time scale again same, but there is condition. So we can say that we can write here it is as x of at. If a is greater than 1, then there will be compressions. दबाव पड़ता है, compression of signal. If a value of a is greater than 0 and less than 1, then it is expansion. There is expansion of x of a, that is from -4 to over 0, x of okay. This is very interesting. So compression when it is condition is that a is greater than 1. A is what? X A T. That means scaling. Scaling is when scaling is greater than 1, that is called, there will be compression of signals. So when scaling is of time is greater than 0, less than 1, that will be expansion of signal. Now see, second one is nothing but time shift. Shifting of time. Okay, time shift. That if this is a signal -1 to 1, okay, and so this is this one to that thing. If we time scale by and where, so what it is actually advance now. If it is time axis it is 0. If we are here, okay, if let us here, and if it is t0, that means we are from here only. Initially we are here, okay, tr, but t1 minus t0. So this is advance. Okay. That means t equals to t0. That means if we shift this signal of xt minus 3, that means t equals to 3. So by 3 unit we have to shift. 3 unit shift. Shift कैसे करना? How we have to take the shift? Now see, if t0 is greater than 0, t0 is greater than 0, here it is 0, positive, then right shift. Okay, we right shift, and if t plus 3, that means t equals to -3, that is less than 0, then left shift, no right shift. Okay, now see what individually we see. So it is shifted by 3 unit, t equals to 3. T equals to 3 unit minus 3 unit. So it is actually called delay, and it is called advance. Why it is advance? We are just approaching before the time axis, so before advance. Okay. Now see, now this one we have to, for this we have to write here, for this we have to write here. Okay. Now See, it is shifted by 3 units. But right, 3 unit means -1 plus 3, that is -2. That is, but here it is shifted right now. Right means this side. So 3 minus 1, that is -2. 3 minus 1, 3 minus 1 is equals to 2 unit. Here this is 1 unit, 2 unit, negative 3 units. It means from 2, negative 3, 4, from 2. This is our shifting. Okay. Now for this one we have to shift left side, this side, by 3 units. -3. So -3 minus 4 plus -3 plus -4, -3 plus -1, that is equal to -4. So it is -4 again, plus 1 plus 1, -3 is equals to -2. So -4. This is nothing but advance. This is what? This is delay now. Delay and here is advance. So basically this is the concept. Negative. So what we have assumed that negative T0 equals to T0. That means shift left side. Shift, that means time advance. That means non-real time operation. Like in offline वीडियो, offline वीडियो में देखते हैं पॉजिटिव हो जाएगा तो T0, that means delay. Possible. Okay. Now see, the third topic is time reversal. Time reversal means folding. Folding of signal. That means rotate the signal with y-axis. Rotate the signal with y-axis. Okay. Like this one. Okay. Okay. Now we will just go through various examples of the time reversal, time shifting, time scaling, and various methods how we will do all this thing. But I think again here we will see what is interpolation and all this thing. We'll see now. Okay, let's take the one example, very good example. Now we will discuss one by one in this. I will take one example and there is various sub question, okay, and we will solve step by step. Understand? You will help me understanding.